Hello everyone. So in this video I will help you get started with building backend REST API from scratch for your SE project. So in this video we will need to install MySQL database, NodeJS and also Postman application. Okay, so let's get started. So in this video I won't be explaining you the steps to install those applications or modules, but I will be sure to upload those documentations in the canvas, so look out for that.
Some of you are familiar with MySQL Workbench, but for those who don't know, MySQL Workbench is a GUI for MySQL. It allows you to design, create and browse the database schemas. Now let's see how to create sample database and table using MySQL. Now to create a database, you can just select this option. Give the name for your schema, which is demo in this case. This will create a demo database for you. Click on apply. So as you can see, a demo database has been created. Now let's create a table inside demo database. So to do that, you can select this option. In order to create a table, we will first need to specify which database we will be working with. So in our case, it's a demo. Then we need to specify a create query in order to create a table. Thus we are successfully able to create a table. As you can see, a green tick mark shows that the table creation was successful. Now let's insert some values into the table. So in this way we were successfully able to insert two tuples into the database. Now let's see the value using select query. Here you can see the table content. Thus MySQL Workbench provides you user-friendly GUI to execute database queries as well as to view the database content.
Okay, so once we have MySQL and Node.js installed, we are good to get started with our application development. So we will navigate to Visual Studio Code. Now here you can see I have written a few snippets of code. So what this means is basically we are importing a module, and this module will be used further in our application development. So to be able to import this module, you need to first install these modules. So one way to do is to use a command called npm install mysql. Now this will install all the dependencies and modules that are required to run that particular SQL module. Now same can be done for Express. npm install Express. So that's it. Once we have imported these modules, we are good to get started with actual programming logic for our backend development. As you can see, I have added one more method, and this is basically a function called initiateDB connection. So what it does, it provides a connection string for our database. So as you can see, there are 4 fields: host, username, password and database. So currently we are working with local database, so that's why the host name is localhost. We have user as a root and then respective password, and database that we will be working with is shopping database. And eventually we will be returning an object of type SQL create connection string, that is connection. I have added rest of the functions that would be required for our application to run, and this is how the skeletal of our program would look like. So there are three functions: add product, add to cart, list product, and there are three routes for each request type like get, post, and patch. And our server will be listening at port 8009. So what route.listen does is it creates a server which listens to the incoming request at port 8009 and accordingly routes the message to respective routes that are defined depending upon the URL that we have specified. A very important point to note here is that this kind of routing mechanism is provided by Express.js library. So if you do not intend to use Express.js, then you can write your own routing logic. So to do that, you will first need to import a HTTP module, and then you need to use a create server method that kind of creates a virtual server and then pass in your user defined function. So in this case, application server is a user defined function. So inside application server, it takes two parameters, request and response. So in order to route the message appropriately, I have written my own routing logic. You can refer to a file shared in the description titled webserver.js, wherein you can find this code. So if request method is get, then in that case a URL is verified against the regular expression, and if it matches the regular expression, then get action would be taken, and as a result list product method would be called. If method type is post, then in that case add product method would be called, while in case of patch, add to cart method would be called by validating the URL against regular expression. So in this way I have written my own routing logic. However, if you happen to use Express.js, you don't have to worry about writing your own logic, because it provides an inbuilt route method which you can use to route your request to perform appropriate actions. So let me give a brief layout of our application. So demo.js is a server-side code. This code runs at the server side and it constantly keeps listening at port 8009. So it is necessary that this application or this piece of code should be kept running all the time, so that it can retrieve the request from the client side. I have also mentioned that we are using Postman application in our development. So Postman application would serve as a client. A typical request in Postman application look like this. So there's a get method, and then we need to specify a URL. If there are any body parameters, we can specify that. So this entire interface serves as a client for our application development process. Now it's time to actually see how the application would work externally. So I will be navigating to Postman application. This is how the Postman UI looks like initially when you have installed the Postman for the first time. To create a new request, you can directly click a new button and then select the request type to be HTTP. You will be prompted to this kind of UI wherein you can select the method type for a request, whether it be a get, post, put. You need to specify URL here. You need to specify if you have any parameters, and then you just need to click send button to send the request to our server listening to the port at 8009. Let's try to get a product from database. For that we will be using get method call, and then we'll be specifying the URL. So as you can see, the URL consists of localhost :8009. 8009 specifies that our server is listening at that port, but for that we first need to start the server. So let's navigate to our code base. Now to run the code, we simply type node demo.js. Now the server is up and running and you are ready to send the request to a server. Now if I press the send, you can see all the products are retrieved from the database. So this is basically a get call, and we have used a select query in backend. So what happens in the backend is that whenever we click send button through our Postman, then request is sent to a server listening at port 8009, which is this server demo.js, and then the request is routed to appropriate function. Now here, since we are using get method call, then message processing takes place in this snippet. So list product method would be called. Let's use HTTP GET call once again, but this time let's use some filter criteria. Let's suppose you have all these products in your catalog and you need to filter out those products based on electronics. So you want to get all the products whose product type is electronics. To achieve that, we need to specify key value pair. So let's say we need to filter it out on product type as electronic. As you can see, these filter criteria are getting appended to the base URL, and when we hit send, you can see only those products whose product type is electronics. This is a typical filter mechanism which can be used in your application. As discussed before, any request arriving at port 8009 would be routed to appropriate snippets. In our case, it would be routed here, and thus list product method would be called. Now list product method takes in two parameters, request object and response object. Now if you have watched video carefully, our URL looks something like this. Now this URL can be manipulated as a part of request object, and then our programming logic can be applied. Okay, now I feel it's high time to discuss how to connect to our local database and retrieve results from it. But to do so, we will require a connection string, and as discussed before, we will be using initiateDB connection method for this purpose. InitiateDB connection takes in parameters like user, password, database name and host. Then we use db.connect method to connect to our database, and once we are connected, then we are good to manipulate our input URL. So request.url gets the URL from request object, and then we will require to split it on question mark and equals to retrieve appropriate filters, in our case product type and electronics. Then we can use a select query with where clause and apply those filters to retrieve the respective results. If none of the filters have been specified, or if URL is something of these lines, then we will use a simple select query and retrieve all the results from the catalog table. Now once we have an SQL statement prepared, we can actually go on and execute the query using tb.query command. Thus, to summarize a GET call, let's take a help of high-level design. In this design, the Postman application acts as a client while the demo.js file acts as a server, and it is listening at port 8009. So any request coming from the client to port 8009 would be redirected to appropriate route method. In this case, it's a GET, and it has a method called listProduct. The listProduct method has our logic, and it is used to retrieve the results from the database, and it basically has a select query that we have seen before. So the retrieved results from database are attached to the response object, and then this response object is sent back to the Postman application, and this is the response that you get. I would also suggest you to go through the lecture slides that explains different APIs like add to cart, add product, list product. That would help you gain a deeper understanding of application logic that needs to be developed for each of those functions. If everything goes well and we are successfully able to execute the database query, then we will need to parse our result set into JSON object
and send that JSON object to Postman API using our response object. So to do that, we will first need to set header using response.set and set the content type as application JSON. Then set the status as 200, indicating that we were successfully able to retrieve results from dataset, and then append the result set as a part of a response object. At the end, we should be sure to close the database connection.
Now let's suppose we need to add products to the catalog. To achieve that, we will need a post request. So in this video, I will show you how we have designed a post request call and how we are handling the same. So as you can see, the method type is post and we have a URL that needs to be specified. Now you can see a body attached to the post request, and this body indicates the product name, product type and price. So these are the attributes that we'll be adding to our database. Okay, now let's hit the send button. As you can see, the response body indicates that the record has been inserted successfully into the database. Now let's check our source code to see what exactly happens in the backend. Now as server is listening at port 8009, any request to that port would be redirected to appropriate route handler. So in this case, a post route would be called, and as a result, add product method would be called. In add product method, what we do is we first initialize the database, that is we define the connection string and then finally connect to the database. And during the process, we also extract the body content from the Postman HTTP API call. So if you remember, we specified the field that we need to insert into the database, and then we parse the body and then insert the body content onto the database. In this case, we are inserting into catalog the product name, product type and price that we have specified in Postman request body. Finally, we set the response type as application JSON and then set the status of response as 200, indicating that we were successfully able to insert data into catalog table, and then sent a response message saying that record has been inserted successfully. Now let's take a look at high level perspective. So whenever we want to insert a product into our database, we do that using a post call with body parameters specified. The server listening at port 8009 redirects the request to appropriate route handler. In this case, it's a post route handler, and add product method is called. Add product method has a logic to insert the data into database, and once the database insertion is successful, we just queue a record inserted successfully as a response message to our application. So in order to verify if your post method was successful and if you were able to successfully insert data into a database, you can just query a get call. Get call basically retrieves all the results present in the database. Since we have used a select statement, as I have explained before, so we can just use a get call to check if our new product has been inserted. So let's do that. Let's verify if we are seeing our newly inserted product using a get call. So you can see the list of all product in JSON format, and this is the product that we recently inserted using a post call, and thus our insert was successful. Now moving on to one more functionality, add product to cart. So you guys might have seen a lot of e-commerce website that has a button add to cart. So what it does, it adds product onto the cart or increments the quantity by 1, so that users can save the items onto the cart and check out later. So if you look closely to request body, there are two parameters: cart ID, which is unique identifier for carts for each individual user, and product ID, which is unique identifier for a product. Now since we have inserted Jump Jordans into our product catalog, the associated product ID is 27. Now let's try to add Jump Jordans onto the cart. To do that, we change the product ID to be 27. We hit send, but you can see that the request was successful and
product ID 27 has been added to the cart and its quantity is currently 1. So if we hit the patch request again, you can see the quantity has incremented to 2 and corresponding price has been updated. So let's see what exactly happens in the backend. Now let's look at the backend logic to see how such functionality can be implemented. Again, any request to 8009, which is patch request, would be routed to patch request handler, and subsequently add to cart method would be called. Again, we will need a connection string to establish a connection with our database. So we will use initiateDB connection method to get that connection string and connection object. Then we will be connecting to our database as we did before. First, we need to retrieve the body contents from a request message, and for that we will use a request.on method. So it will extract all the fields that are present in the request body. We will parse that field and then we will get product details for a particular product ID from a catalog. So details like quantity, price, discount, and product name would be retrieved using this select query. In order to find the quantity of a product in a cart, we will be using this query, select star from cart item. Now cart item is the table that stores a quantity associated with a particular product ID and cart ID. So this is how the table looks like. So we are storing a quantity associated with a particular cart ID and product ID, as well as overall price, which can be computed based on discount and quantity. Now we retrieve the quantity of a particular item present in the cart. If that quantity is undefined or the quantity is null, then we haven't inserted the product into cart yet. So we will do that using this formula. This takes into account discount as well as the cost price associated with that product. Now if the product is already present in the cart, then we need to increment its quantity by 1. So here you can see the quantity has been incremented by 1, and then based on the discount and cost price we are computing the overall total cost. Now we need to insert this total cost into our database, and for that we will be using upsert query. An upsert is combination of two words, update and insert. It works on a concept called duplicate key. So if a key is already present in the database, that is primary key is already present in the table, then it updates the quantity by 1, and if the primary key is not present, then it adds a new primary key onto the database. In our case, primary key is combination of cart ID and product ID. In this way we have updated the quantity, and now it's time to update the price associated. So we use this update query to update the price associated with that particular product in the cart. Then we calculate the total overall cost of cart, taking into considerations all the other products, and that can be achieved using an aggregate SQL query. Finally, we append the total cost of cart in addition to other attributes and send it as a response object. Finally, we have this response, which consists of cart item ID, cart ID, product ID, price. Price is an individual price associated with that particular product ID, taken into consideration quantity and discount. And finally, a total cost of cart, which takes into consideration all the other items present in the cart for a cart ID of 1. Well, that's it for the video. So Express.js module really eases out the development effort when it comes to backend API handling. Finally, let's switch to high level perspective. So whenever we want to add an item to a cart, we request a patch method from a Postman application with body parameters as a cart ID and product ID. The server listening at port 8009 redirects the message to appropriate route handler, and as a result add to cart method is called. add to cart method has a logic to insert or update the quantity of an atom in database, and whenever the insertion or updation is successful, we kind of attach a response object with additional parameter as a total cost of cart, which we compute using our application logic, and return this response object back to the Postman application. And that's what you see in the Postman response object.
Well, that's it for the video. So if you have any doubts, feel free to discuss in the comment section below or reach out to me via an email.